Pretty sweet, right? All right, so look, here's some extra examples. As you try these, remember, I didn't put this into the paint or whatever, but you've got to look at the point because that's how you know it's a pyramid. Across from the pyramid is now going to be a triangle, okay? So then, as we saw in the last um, examples, you always have to find the area of the original base, right? Because the base shape in 2 dimensions is now made 3D by going up to a point. Okay, so this base goes up to a point, and that's what makes it a 3D shape, and that's what makes it volume, not area. But on these questions, they have triangle bases. So then you're going to have to change the formula um, for creating these 3 dimensional shapes, right? Let me see. Let's use a reaction now. Let's go ahead and create a trapezoidal pyramid, okay? We know the area of a trapezoid is always 1/2 base 1 plus base 2 in parentheses times height, correct? If you were going to make this pyramid, you'd have to find the area of this trapezoid first before you made it 3 dimensional. Because after this, you're going to multiply it by a 3D height, and then you're going to multiply the whole thing by 1/3. So this is what happens. You find the area of the trapezoid, then you get to the point. Boom, 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 boom. This looks freaking weird. Looks terrible, actually. Let me give it a different right here. Let's go ahead. Right here. Boom, 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 boom. Right now, the trapezoid is a pyramid, even though it looks not very great. You multiplied it by 1/3, also because then otherwise, like we just saw, the older teacher guy in the video, we saw how he said it was 1/3, right? So I'm just trying to make sure you guys understand that this is essentially a 2D shape taken up to a point to make it 3D. Let's try out some cones, okay? Once again, the formula looks different. The formula looks different, but it's the same deal. See, it says 1/3, or actually, let's just go with this. It says pi r squared, okay? Before in the last ones, it said b times h times 1/3, 1/3 b times h. But you have to realize pi r squared is the base because pi r squared is the area of a circle. On a cone, what's the base? What's the base of a cone? The base of a cone is a circle, pi r squared. So pi r squared creates the base. And again, to make it 3D, you multiply it by a height. That would make it into a cylinder. But then we only take 1/3 of that cylinder, and that's what makes it into a cone. So on this question here, look for the radius. It's already 9. Jeez Louise, get out of here. It's already 9. So then it's pi times 9 squared. That creates a circle. Multiplied by how tall is this pyramid? Woo! 17. And then lastly, cut it into a pyramid. Chisel it out. Like the Egyptians back in the day, right? Boom, they cut it into a pyramid. We cut it into a pyramid by multiplying by 1/3. Now, once again, Desmos this thing and figure out what the volume of the cone is. 1/3, 9 squared. Pi times 9 squared times 17 times 1/3. Let the calculator do it for you. The volume of that cone is 1,441.99 or 1,442 if you round it up. 1442, 144, let's see, 2. Why not? Yards to the 3rd power cubed. The only thing you really have to look out for on these questions, well, I guess, is if they don't give you the radius for one. That's one thing you might want to look out for. You don't want the diameter. And then also, look, this guy's also going to make you do the Pythagorean theorem. I'm sorry. Unless you guys in your class like Pythagorean theorem, but my kids don't like it. Just yeah, you might have to find the height here, b, and then cut this in half. 27 divided by 2, 13.5. Right. Those are challenge questions. I'm not so sure that. Whatever. But yeah, that's how you do all this stuff, guys. I hope you have a good rest of the year. Let's check out a video of Wee Man inside of a cone real quick, and then we'll be done.